Lesson 23 Project Video Help. In the previous two lessons, you analyzed the flight paths of the Dragon, Sally, and Chelsea using angle measures in degrees. However, as you've learned, radians are the preferred angle measure in higher level math classes. Let's revisit Sally and Chelsea's flight paths, this time using angle measures in radians. In the project for lesson 21, you saw that Sally likes to take off at an angle of 7 degrees and Chelsea likes to take off at an angle of 13 degrees. Convert these angles to radians and round your answers to the nearest hundredth. Alright, so let's start out with Sally. She has an angle of 7 degrees. So we're going to take that 7 degrees. If you remembered how to convert to radians, we multiply our degree measure times pi over 180. Now usually we would leave our pi in our answer, but they say they want our answer rounded to the nearest hundredth. So that means that in my calculator I'm just going to type in 7 times pi divided by 180. And I'm going to get an answer. And then the hundredth place is 2 decimal spots. So when I type this in, I get 0.12 radians as my answer. So all I do is type that in. Hundredth is 2 decimal places after. So now let's go to Chelsea, who has a takeoff of 13 degrees. So we're going to do the same thing. Take the 13 degrees, multiply it times pi, divide it by 180 degrees. Type all that into the calculator, round it to the nearest hundredth, and we get 0.23 radians. So there we have both of them converted to radians now. In the project for lesson 22, you used the following diagram to analyze Sally and Chelsea's flight paths. That's the one on the bottom right there. To their workplaces via their favorite coffee shop. The angle that represents Sally's travel to work from the coffee shop is theta equals 2.52 radians. What is sine of theta? Well, if you use the online tool, here in the box it says theta in radians, which is what we want because our theta here is in radians. And I just typed in the box the number 2.52 because that's my radian measure. Hit enter like it says. Then I went down here and I hit calculate, and then it gives me the value of sine, cosine, and tangent. So I need to read my question. What is sine theta? I want to know sine theta. So that means I'm going to look at just my sine theta. So my answer here is 0.58. That would be my answer for what sine theta is. Refer to the diagram in the previous question, so I have it here to the bottom right again. The angle that represents Chelsea's travel to work from the coffee shop is beta equals negative 0.19 radians. What is cosine of beta? So again, I use the online tool, make sure I'm in radian mode. So it says theta in radians, type in the negative 0.19 since that's my beta angle. Hit calculate, and it gives me sine, cosine, tangent. So my question asks me what is cosine of beta. So I'm going to look just at the cosine beta, and that means that cosine beta is 0.98. My cosine value is 0.98, so cosine of beta is 0.98. Since Chelsea sits in a chair as a police officer, sits in a car, not a chair, sits in a car as a police officer, she likes to exercise on her lunch break. Her wings get a workout when she flies to and from work, so she needs to exercise her legs. To do this, she runs around a circular track. If she can run 4 laps in 3 minutes, what is her angular velocity in radians per second? Hint: start by figuring out how many radians are in 4 laps and then figuring out how many seconds are in 3 minutes. Well, if we look a track that would be circular, we need to know how many radians are in a full circle. Well, a full circle has 2 pi radians. So that means each lap she's running 2 pi radians, and she does a total of 4 laps. So I'm going to take the 4 laps and multiply times 2 pi, since that's how many radians is in each lap. And I get that she does 8 pi radians. And then figure out how many seconds are in 3 minutes. So we got 3 minutes. And multiply that times, I know that there are 60 seconds in every minute. So my minutes cancel out. 3 times 60 divided by 1, type it in the calculator, or if you know it, it's 180 seconds. So now I want to know it in radians per second. So I'm going to take my radians divided by my seconds. So I'm going to have 8 pi divided by 180. Type it into the calculator, round it to the hundredths, and I get 0.14 radians per second. Hope that helps with your lesson 23 project.